So tangent and cotangent have some similar characteristics, but they are different. Unfortunately, when we graph secant and cosecant, we could treat it like it's reciprocal function, but that's not the case with cotangent. Cotangent behaves differently than the tangent. And really it's because tangent and cotangent are undefined at different places. Remember, we just talked about the unit circle. Remember, tangent is undefined at 3 pi over 2 and pi over 2. Cotangent is undefined at 0 and pi. So what happens when we graph a cotangent, again, we're graphing one cycle, we're still going to have the beginning and end, start and end with a vertical asymptote. However, because cotangent and tangent are undefined in different places, we're going to be graphing one cycle from 0 to pi. Just like tangent, cotangent does have a period of pi. So, just some characteristics for cotangent. Again, cotangent is reciprocal of the tangent function. And it is undefined where tangent of x is equal to 0. So tangent of x, thinking back to your unit circle, is equal to 0 at 0, pi, 2 pi, 3 pi, 4 pi, 5 pi, etc. So it's at all multiples of pi. So for the parent function, cotangent is undefined at any multiple of pi. Just like cotangent, cotangent is an odd function. So remember the algebraic definition of being an odd function? That means that the cotangent of negative x is equal to the negative cotangent of x. There is only 2 even functions out of the 6 trig functions. Cosine is even, its reciprocal function secant is even. So cosine and secant are your only 2 even functions. The remaining 4 are odd functions. All right? It has no amplitude. That only applies to sine and cosine. Because remember, when we look at the graph, there is no max or min for cotangent. Period is pi, just like the tangent. So tangent and cotangent are the only 2 trig functions that have a period of pi. The other 4 will have a period of 2 pi. Like I said, the parent function interval is going to go 0, less than your bx minus c, less than pi. So we're going to graph the parent function from 0 to pi for one cycle. Again, use your compound inequality. If you have a period and or a phase shift. And again, your bookend is going to be that 0 less than b, x minus c, less than pi. Just like tangent, cotangent is going to begin and end your graph with a vertical asymptote. And just like all the trig functions, to find your phase shift, it must be in the form of y is equal to a times the cotangent of b times x minus c plus d. Just like all the other trig functions, again, you want to make sure that that b value is factored out in order to find your phase shift. Remember, the c value is your phase shift. So we'll graph very similar to the way we've been doing, finding your vertical shifts, finding your baselines, using the bookend methods and the inequalities to find your start and ending places. Again, the big thing is, remember, the interval for cotangent 0 to pi. Remember, tangent is the only one that doesn't start at 0. Tangent, when you start graphing, starts at that negative pi over 2. So all the others will start at 0. So let's take a look at this parent function here for cotangent. So when I look at my parent function cotangent of x, again, I'm going to graph it from 0 to pi. So to find the divisions along the x-axis, I know halfway between 0 and pi is pi over 2. Halfway between 0 and pi over 2 is pi over 4. Halfway between pi over 2 and pi is 3 pi over 4. So those are the divisions along the x-axis. Where's the baseline for the parent function? The baseline is just your x-axis. The a value is 1, so I know I have 1 unit above, 1 unit below. Just like tangent, we call it a vertical stretch or compression, but we can use that A value to help us calculate the other points on the graph. So remember, we're always going to start and end with a vertical asymptote. So the divisions along the x-axis will be pi over 4, pi over 2, and 3 pi over 4. So now going back to your unit circle, what is the cotangent of pi over 4? Well, what's the tangent of pi over 4? You're in quadrant 1, so I'm positive. So the tangent of pi over 4 is 1, so then what's the cotangent of pi over 4 going to be? 1. Cotangent of pi over 2. Remember, tangent is y over x. Cotangent then would be the x over the y values. So just because tangent is undefined does not automatically mean cotangent's undefined. So remember, cotangent is the x over the y value. So remember, on your unit circle, you have that ordered pair up here at 0, 1. So if it's the x over the y value, then what's the cotangent of pi over 2 going to be? It's going to have to be what? 0. And then the cotangent of 3 pi over 4, again, 3 pi over 4, you're in quadrant 2. Tangent and cotangent are negative in quadrant 2. So that's going to have to be your negative 1. So then at pi over 4, your y value is 1. Pi over 2 is at 0. 3 pi over 4 is negative 1. So there is your parent function for cotangent. Yes, a cotangent graph looks like a reflected tangent. Just like we did with those when we were writing equations given the graphs for sine and cosine, you could take every graph and write it as a sine or a cosine with phase shifts. Same thing with these tangents and cotangents. The domain, remember, is all real numbers.
All real
Except multiples of pi. So any multiple of pi, the parent function cotangent's undefined. 0 pi, 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, 7 pi, etc. The range, just like tangent, if you look at the curve, is going to be all real numbers. The period is pi, and your vertical asymptotes for the parent function are at x equals 0, x equals pi. So the big change, guys, from doing a tangent versus a cotangent is really the interval that we're doing. We're going from 0 to pi instead of negative pi over 2 to pi over 2. Again, you find the period exactly the same way as you do for tangent. It's pi divided by the b value. Okay? So let's take a look at the transformations now. So let's take a look at number 1. 2 times the cotangent of x minus 1. Well, what's the period for this one going to be? The period's going to be, well, what's your b value? B is equal to what? 1. So it's going to be pi divided by the b value. So the period's going to be pi. Do you have a phase shift? No. Do I have a vertical shift? Yes, I'm going to do what? Go down 1. So now I have this 2. Remember, that's my vertical stretch. So my vertical stretch is 2. So remember, that's the a value. So I have no period change. I have no phase shift. So the labeling along the x-axis will be exactly the same as the parent function. It's going to go from 0 to pi for this particular cycle. So then my divisions will be the pi over 4, pi over 2, and 3 pi over 4. Now, where's your baseline going to be? So again, I know my baseline is going to be down there at negative 1. So at negative 1 is my baseline. So my a value is 2, so that means those other key points will be 2 units above the baseline, so that'll put me up at 1. 2 units below, which will be put me down there at negative 3. So remember, just like tangent, my cycle is going to begin and end with vertical asymptotes. So I'm going to have a vertical asymptote at 0, a vertical asymptote at pi. There is no reflection. So looking at your parent function, remember, we started with a point above the baseline, then it was a baseline point, and then the point was below. It's opposite of the tangent. So if you want to help remember what we've been talking about, at pi over 4 will be a max, pi over 2 is a base, and then 3 pi over 4 is minimum. Remember, technically they're not maxes and min because there is no max and min. But at pi over 4, I have to be 2 units above the baseline, which will put me up here at 1. Pi over 2 is a baseline point, which will put me at negative 1. And then at 3 pi over 4, I'll be 2 units below, which will put me at negative 3. So this is what your cotangent curve with the vertical stretch and vertical shift is going to do. So my asymptotes are at x equals 0 and x equals pi. So any questions on graphing cotangent? Right. So let's take a look at another one. So looking at number 2, what is your period going to be for number 2? Well, what's the b value in this equation? The b value is a what? 2. So the period's going to be pi over 2. Because remember, it's pi over b. Do we have a phase shift? No. Are we shifting this graph up or down? Is there a vertical shift? No. But now, what does this negative sign in the front tell us to do? We are going to have to do what? We have to do a reflection. And we have a vertical stretch by 3. Remember, that's the a value. So now, because you have your period change of 2, it's going to affect the way you label your x-axis. Remember, it's going to go from 0, less than 2x, less than pi. So if I divide by 2, 0 less than x less than pi over 2. So this cycle will start at 0, but now it's going to end at pi over 2. So now what is the halfway point between 0 and pi over 2? Take pi over 2 and divide it by 2 or multiply by half. Halfway between 0 and pi over 4 will be pi over 8. Now, pi over 4 to pi over 2, remember, you have to add those together. So pi over 4 plus common denominator, you can write pi over 2 as 2 pi over 4. That gives you 3 pi over 4, and when you divide by 2 or multiply by half, that'll give you a 3 pi over 8. So any questions on how I found the divisions along the x-axis? Where's the baseline? Baseline's what? 0. It's just the x-axis. The a value is 3, so I know I'll have to be 3 units above, 3 units below the baseline for those other points. Remember, it's a cotangent. You're going to start and end the cycle with those vertical asymptotes. Now remember, it is a reflection. Remember, with the parent function, the first key point will be above the x-axis. So just like we've been doing all along, what happens with those max and min points when you have a reflection? They're going to do what? Switch. So because of the reflection, your first key point, instead of being a max, will be down here at the lower point of negative 3. And then it's a baseline, and then it's going to be a maximum. So pi over 8 is negative 3, pi over 4 is 0, 3 pi over 8 is 3. Just like with sine and cosine, you can take every cotangent graph and write it as a tangent curve with a reflection and or a phase shift. So there is multiple equations you can come up with for every graph for tangent and cotangent, just like you can for sine and cosine. All right, any questions on that one? You guys go ahead and try number 3 for me. Go ahead and try graphing number 3. You only have one translation, which is what? You only have to do that vertical shift.